Hello everyone, in this video we're going to be talking about using chi-squared in geography. Now what chi-squared does is not too dissimilar from Spearman's rank, but it looks at an association between data. So you can't use it if there's only 2 bits of data. Often it's used in a table. It can be a very small 2x2 table, 2x1 table, or as big as a 6x10 kind of table incorporating huge amounts of data. And what it looks at is there an association between the data in the table. So we do want to avoid using the word correlation. So the first thing to do, the easiest thing to do, is work out the total of our rows and columns. Now the numbers that we've got, they are our observed values. That's what we've been out, we've collected data, and we've observed that this is true. So the first thing we're going to do is very simply work out the total of the row and the column. So as we can see, we've got 20, 30, 30, and then 34, and 46. Now you'll know you've done them right because they should add up the same way downwards as they do across, and obviously we have 80 respondents. Now this is the example that's in your fieldwork and research booklet, and you'll see what they've done in here is divided it into a table, into observed, that are the numbers simply in the table, are expected. Now this is by far the easiest way to work out our chi-squared. We simply list out a table and then we can put in the observed, the expected, and just do it step by step. And that's what I'm going to do next. So you can see here, this table simply looks at all the possibilities, all the combinations of answers that we can have. So for example, we've got under 75s who are also in the under 20,500 bracket, under 75s, which are over 20,500 and so on. And the first column is simply the observed. That would simply copy in the table into this. So you can see here, all I've done is copied our observed, the actual data we've collected, and I've added it into our first column for our observed data. Now we're going to move on to our expected data. Now this is why completing our rows and columns total is important, because we need that. Because all we do for each one, we do the row times the column total divided by full total. So I'll do the first couple with you. So you can see the first one is under 75 and they're earning less than 20,500. We can see for 14 that the row is 20 and the column is 34. So we will do 34 times 20 divided by 80. That gives me 8.5, and then I can do exactly the same for each one. Under 75 over, so this time I'm using this one, so it's 20 times 46 divided by 80, and I'll do that for each and every one of them. So this one, 30 times 34 divided by 80. This one, 30 times 46 divided by 80. This one, 30 times 34 divided by 80. And then all I'm going to do is add that number into what we call the expected column. And here is my expected numbers. Hopefully you've got something similar. My next step, again, if I have a look at the example in my fieldwork and research booklet, is I simply do observed, take away expected, and then I'm going to square that number. Always remember that when you square a negative number, it becomes positive. So when you get onto that O minus E squared column, it should always be a positive number. So for example, in this one, I would do 14, take away 8.5, which is of course 5.5. I'm then going to square that number, which gives me 30.25. If you do the next one, you'll see that it's a negative. It becomes minus 5.5. But when I square that, that becomes positive 30.25. I'm just going to do that for each of the numbers on this list. And as you can see, I've now got that almost completed. The final step is I take that final column, the O minus E squared, and I go back and divide it by the expected number. So I'm going to do O minus E squared divided by E. So in this example, I will take 30.25 and I'll divide it by 8.5, which will give me 3.56. I'm not a mathematical genius, by the way. I've worked it out earlier. I'm just adding it in. we can see this one here, 30.25 divided by 11.5 is 2.63. And I'm going to do that for each on the columns. And you can see I've done all that column now. And all I'm going to do is work out the total of this column here, which comes to 9.34. Now this is our chi-squared number. It doesn't really mean anything on its own. We first have to compare it to the critical value. So here's our critical value table. So which of these many numbers are we going to use it to? So the way we work that out is it's how many rows do we have, minus 1, times how many columns do we have, minus 1. So we've got 3 rows, minus 1 is 2, times 2 columns, minus 1. So we are going to use 2 degrees of freedom. And this question asks for 5%, which, as I explained with Spearman's rank, is this one here. 0.05 is the same as 5%. So that is what we want to match up 2 with 0.05, and here is our important number, the 5.99. So we've got 9.34. The critical value is 5.99, and our number is obviously greater than 5.99. Now that means we reject the null hypothesis. That's a double negative. It means that there is an association between height at 1 year old and the income that they earn later in life, because our number is greater than the critical value. So I hope that's helped you understand chi-squared a little bit easier. It shows association between data, and if we apply it to this one, apparently if you're tall at 1 year old, there's a good chance you'll earn more money in later life, apparently. So got to be careful of causation, of course, but it shows there's definitely an association in the data that we've collected between those variables. Thank you very much, guys, and I'll see you all soon.